Hello everyone. In this video, we are going to talk about the partitioning in Spark. So what do we mean by partition? What is the need of the partition and how we do partitioning in Spark? So first we need to understand what is partitioning. Partitioning is the division of the data. Be if you are using Hive or if you are using any of the database RDBMS system, you would be knowing about the partition. So partition means the division of the data, like so that you don't have to do the full table scan. For example, a table have around millions of record, and you have to search any employee, like select a star from the table where employee name is Santosh. So it will do the full table scan. It will read each record in that table to get the particular matched record. But when you partition it on the basis of department, for example, IT department, HR department, and in the SQL or in the any of the queries, if you write, you can write a query with the help of Python or with any other language. And in the where clause, if you give the partition name, so where partition, where department equal to IT, then it will go into the IT department and search for the particular employee. The same kind of concept lies across all the databases, and it also lies in the Spark system also. So we do the partitioning in Spark to get a better or to optimize the searching in the system, and also to optimize the overall Spark performance. Now you'll understand that how the partitioning impact the performance of the Spark application. Now I'll create three executor. Sorry. So now I'm going to create three core or a three node, not core. I was talking about the core node. So I have three node, and each may have one CPU or multiple CPU. Now I have a chunk of data which is already partitioned. So I have around, for example, one partition, two partition, three partition, four, and five partition of the data. Now, if this has to be assigned to this node, so I can assign this to this one, and this will be done automatically by your Spark. We don't have to do anything for this assignment. So it will be assigned to this node, and this will be assigned to this node. Now the other one will be assigned again to this, or it can be assigned to this. Fine. So this way, this partition are being assigned to different nodes. Now we take an example. For example, I have, instead of this many partition of a file, if I have a huge file having a single partition, I mean to say, for example, I have a huge file and there is no partition into it, and this is a huge file, so it contains a single partition. So it may be assigned to any of the node in this situation. For example, it is assigned to this node. So in your cluster, the other nodes are not in working state, means I mean to say other nodes are not working on this file. As this file's data are not partitioned, so it is being assigned to a single node. So this nodes, node number 2 will be overloaded with the work, and node 1 and node 3 don't have any work regarding this file. So your cluster will be not utilized proper, and it will impact your Spark application, performance of the Spark application. Now consider another example where I make the partition of these files, but there are many number of partition. For example, I have this file, but I have created around 1000 partition. Now there are 1000 part of this file, and it will be assigned to this three node one by one. So in this case also there is a problem, because the management of this partition will be an overhead. Second thing, your data will be divided into small chunks. So there will be altogether different issue of a small data set or small chunks of data distributed in the Spark system. So for getting the proper optimization or getting a proper Spark application optimization with the help of partition, we should know on which column we have to do the partition, and also we should know that how much of the partition we have to do depending on the resource, depending on the cores available to your application. Now with an example, we'll understand what is the output of the partition when we apply partition in any file. So what is the output of it? So I have written a simple program in which I'm reading a CSV file. So I'll just comment this one. We don't need any this kind of configuration now. So I'm just reading a CSV file. The file name is bookscrap.csv, and I got this from Kaggle. I downloaded this data set. It have around 6 to 7 columns, and it is about the book name, book rating, and in which category the book lies. Okay, so first I'll show you the what is the data into it, and then we'll look into the partition. I'll run this program. So this kind of data is there: title, book category, star rating, price, stock, quantity. Now this is having around 65 or 700 KB of data. I don't know the number of records, how much is there, but it's a huge data. And in this, I want to partition on the basis of book category. So all the data in the book category poetry will be in a single folder, and all the data of business category will be in another folder. Fine. So what we are going to do, we are going to write this CSV which I have read now. Okay, and this one I'll do it later on. First I'll copy this. I'll in the later in this video I'll make you understand what is the repartition concept here. So what I'm going to do, I'm just going to write this data frame which has read this CSV file, and I'm doing the partition by on book category. Okay, done the override, and the folder name is partition underscore output. Okay, so now when I'll run this, let me save this. So it will create a folder called partition underscore output, and it will create a different folder on the basis of book category. So if I refresh this, so we'll get this somewhere in the folder will be there, partition underscore output. And you see you have a folder name being created, book category equal to academic, and in this we have another Parquet file which contains all the data of the academic. For example, arts, so all the data of the arts. So if you write on the top of this, if you have a table and you have write a query, and if you write a query, select some book name where book category is academic. So the query will, or the Spark engine will search, or Spark SQL engine will search inside this particular partition. It will not do the full scan. So that is the advantage, and this is how it works. Fine. Now the thing is, we have to understand the biggest problem in doing the partition is which column needs to be partitioned. This is very important. We need to understand this in our application. Each application will have a different way of understanding the column, business column, and how the data is there, or which kind of data is there in the business column. If you have a data of a lot of unique data, for example, if you have a customer table or customer table in which there is a customer ID, so ID is considered generally unique across the industry. So ID will be unique, and there will be a lot of unique values in the customer ID. So if you create a partition by on customer ID, then customer ID multiple or too many of the folder will be created on the different customer ID, and in each folder there will be only a single record. So that is a very bad idea. If your uniqueness is a lot in a particular column, then we don't have to go to or we don't have to consider that particular column as a partition column. The second thing, in any column, if we see that the downstream application who is going to read your data, or in your application also, if you're going to read your data which you have already saved, and in the where clause or in the join clause, if you have to see that maximum on which column you are doing the filter, applying the where clause, a maximum in which column you are doing the join. So in that condition, make that column as a partition column, so that during the join also a particular partition will be only shuffled. and during the filter also the table will do the scanning on particular, or the Spark will do the scanning on that particular partition folder. Fine. So these are, by this way you can make a better choice for your partition column. Now we'll see that we can do the partition by on two columns. For example, I have a big book category, and there is one more column into it, which is the star rating. So what I will do, I'll just, so you can do in a multiple column. So this is for the two columns I am doing multi-column partition. So if I run this partition, this program, so I've written the override mode. So every time your this folder will be recreated. So if I save this and go into this, so for each bigger partition, book category, parent partition, you'll have another child partition. So there was only one rating of the rating 2, so there is one partition, sub partition into it. Similarly, if we go into art, so we have multiple ratings inside that. So if we have multiple child partition or the sub partition, and it will be having a multiple files into it. Fine. Now, one thing to know is how we write, the order of writing this partition. If you are using multiple columns to partition, so the order in which we are writing this partition matters a lot. It will give the result matters a lot on that. So in this case, you see, book category is the one way, the bigger partition, and star rating is the smaller partition. If I change this, means, okay, so I made the parent as a star rating and the book category as the sub partition or the child partition. So now if I go to, if I'm running this program, okay, it has created the partition. Now you see, your rating is the main partition, and inside that you have a different category of the books. So if you're writing the same query which we have talked just few minutes back, so if you're going to write the same query which we have discussed now, like get or get the a book which is of a type business and which has a rating 4, so then that query will not be much optimized, that execution will be plan will be not much optimized, because the way how we are searching inside the partition is very different from the query perspective, and the way we have created the partition is very different. So this ordering of this partition is it matters a lot. So we should always understand, we should always do some kind of testing before going into the production for the partitioning thing, and we should also analyze like how the data is being distributed and how the queries are being written, and accordingly you have to decide on how we need to partition, on which order you need to partition. Now we'll look into repartition, in which you can create a multiple partition inside the partition. What I mean to say, like for example, in this you have only one part. You can have multiple part, or you can have a multiple partition inside this partition. So if you have a very big file, or and in each section, if you have too much of record, so you can further partition it, and that can be done, and that will be good for the distribution of the data. It will distributed across the different executor. Okay, so now what I'm going to do, I'm just going to comment this one, and I'll run this command. This I'm reading this data frame, I'm doing the repartition. I'm telling that make the number of partition inside this partition, or repartition the inside data into 5 partition. Okay, and then this other thing will remain same. Now remember one thing, when you do repartition 5, it will try to create a 5 partition, but if the data is not sufficient, you don't have that much of course, so in that case the repartition will maximum try for 5, but it can give the result with the less number of partition also. You can try in your system, you'll get the same kind of result. Okay, Now this has been created. See, in academic, there's only one part. In arts, you have multiple one, two, three, four, five. So it created a five part in this art. So this is just because of adding this repartition file. Fine. Now we will look into how we can increase the number of partition with the help of size, and by default how much partition is there. So we'll just look into how to count the number of partition and all that stuff. Now, for example, we are reading the file, and uh, we are we want without using any of the partition. I want to understand that how many number of partition, or like how many chunks of the data is there by default. So I'm not doing any repartition or any partitioning of the data. So this partition is generally creating the folder and for the better scan. So now I'm going to check the chunk, because when you are reading the file and if you have not done any kind of repartition, so sometime what happen, you may have only a big chunk of file, and that will be considered as a single partition, and it will hamper the reading process also, because in the reading itself, when you give this option, it creates a job inside the Spark. Now what I'm going to do, I'm just going to calculate the number of partition with this. Okay, so I'll just save this. So how to calculate the number of partition? So we have a function called get num partition, but this works on RDD. So I created this, I converted this data frame into .rdd, and on that RDD I am running the function get num partitions. Okay, so by default it has given me the one partition. So by default, it has given me one partition, and it is very dangerous if you have a very big file and you are working on a single partition. So now what I'm going to do, like if I have to see the size of this file, so I'll do one thing. I'll go into the file. First, let me just close this one. My file name is bookscarp. I'll just terminal. Okay. So I have this book here. So minus h. Okay, so there was some typo error. So du minus h, I want to see the size of this file. So it is around 76K. So now what I will do, I will just, there is one configuration in the Spark where you can set, when you created the Spark session on that variable itself, you can set .conf.set Spark SQL files max partitions. So you can give the value of the max partition bytes. So when the data will be partitioned, what will be the chunk size of the data, that also you can give. So, and this is very important to what you call, to avoid the small part in a program. Like if you are reading a file, and by somehow doing some transformation, or the way we have repartition, and on that basis, if there are very small chunks of file being created, then it will create a problem in your application. It will hit the performance of that application. So in that case, you can use this configuration, and it is considered safe, and it is advised to use this kind of configuration in your configuration file, not inside the program. In some of the videos, I'll explain you how to put the configuration file. So you can write Spark SQL files dot max partition bytes, and you can give this in a bytes. Like it is 1000, that means 1K, 1 kilobyte. So if you apply the maths, it will have around 76 partition if we apply this configuration. But this 1000 bytes will be the maximum value of the chunks. It can have the less values also of these chunks. Okay, so we'll see that how many partition it creates. Okay, I have done this one. I'm just getting the number of partition. Right. So it has created around 75 partition. So if we would have not used this configuration, then you would be getting one partition. But now you are getting around 75 partition, and it will be distributed across the node. I hope you would be able to understand the full partition concept, in which scenario we have to choose which kind of column, and how the number of partition hamper the Spark application. If you have any doubt, please mail me or ping me. Thank you.